Okay, welcome back to our note 7-7 transformations. In example 2 here, we want to identify the parent function and then describe the transformation that was performed. So in this function, I see that my parent function is 2 to the x, just a base and an exponent. So I see the 3 and the plus 1 are transformations done to this base exponential function. The 3 is a vertical stretch by 3, and the plus 1 to my x shifts it to the left 1 unit. All right, so B, if I'm trying to look at this as a base parent exponential function, my parent function I see in B is 7 to the x, just a base to a variable of x. So I see that minus 2 on the end is going to shift it down 2 units, and the 2 multiplied by my x is a horizontal compression by the reciprocal of 2, which is 1/2. So we see our parent functions are always a base only to an exponent, and we look at all other numbers as a transformation. So now let's go on to our logarithmic transformations. So for part C, parent log function to me is log base 3 of x, just a basic log of x. So the 2 in front of my log is a vertical stretch by 2 because 2 is greater than 1, and the 1 added to my x shifts it to the left 1 unit. So our parent log functions are log base something of x. Moving on to D, k of x is negative log base 4 of 2x minus 3. So my parent function is log base 4 of x. The minus 3 from my x shifts it right 3. The 2 multiplied by my x, it was horizontal compression by 1/2. And the negative in front reflects across x-axis. So now here, back to an exponential function. So my parent function is 3 to the x. The 4 in front is a vertical stretch by 4. The negative in front of my x reflects across the y-axis. And adding 2 to my x shifts it to the left 2 units. So when we are looking at logarithmic and exponential functions, we should be able to identify the base parent function and the transformations that are being described by the given function.